All right, atomic structure 5, we're talking about the alkaline earth metals, the second most reactive metals on the periodic table next to the alkali, which we talked about in the last video, the alkalis, and they're a group 2, so they're to the right of the alkalis. Now, the alkaline earth metals, kind of strange to call them earth metals because, well, they're found on Earth, but so are other metals that are found on Earth. But the reason why they're called alkaline, and we'll talk about that in the video, is because they can form solutions with a pH greater than 7, and I'll explain that in the video. So like the alkali, here they are. Here they are. Let's get the pen going. And we'll say red. So right here we have the alkali. This is a group 1, and these are the alkaline earth metals. Just making it with radium. Radium right there. Okay. So like their neighbor to the left, the alkali, they do not like to be alone. So let me write that up here. They do not. They don't like it. They don't like to be alone, right? So in other words, they react with other elements, just like the alkali. So in nature, you won't find them alone. In nature, you will not find them. As I run into these other metals here, find them alone. You won't find them alone. So they react. And so they have an ability to combine with other elements, just like the alkali. And they have, right here on top of here, they have two valence. They have two valence electrons. In the last video, I talked about the alkali. They had one valence electron. So do you remember what valence means? Well, the valence electrons are the last electrons, the electrons in the last shell. And let's show a picture of that. Like here's magnesium, right? It's an alkaline earth metal. And so if you look, and make sure we have our pen ready. So if you look at the shells, remember we talked about these, there's the K shell, the L shell, and the M shell. And if you look at the last shell, this last ring, there are two valence electrons. Those are the last electrons, the electrons in the last shell. Now, I also talked about subshells here, that you could actually have some D shell subshells included in the valence electrons, which I talked about in other videos. So here they are, right? And we'll put in group 2 over here. Group 2, as you can see over there, there's a 2 also. So we have our beryllium. There's beryllium over here. Here's magnesium, I just circled. Calcium, strontium, barium, and radium. And radium, let me write here, radium is radioactive. Just like if you think to the left, what we talked about in the last video, francium right over here, which is an alkali, is also radioactive. So again, radioactive is they're giving off radiation, which could be dangerous. So as far as the alkaline earth metals, radium is radioactive. And it is also one of the most reactive of the alkaline earth metals. Just like the alkalis, as you go down, here's our arrow going down, as you go down, they become more reactive. So the alkaline earth metals are the second most reactive metals on the periodic table, like I said before. And again, as you go down, they become more reactive. So which one would be more reactive? Calcium over here is calcium. Or would it be magnesium? Which one would be more reactive? What do you think? It would be calcium because it's down, right? It's in a different row. And how many rings do you think, if we want to test our knowledge from previous videos, how many rings or orbits or shells would calcium have? Just look at the periodic table. So it's in row 1, 2, 3, 4. It's in row 4. And if it's in row 4, it has 4 rings or 4 shells or 4 orbits. All right, and here it is. Here's calcium. And again, it has 4 orbits. And just to review on the subshells, remember we have the K shell, the L, the M, and then that'll be the N shell. So It has its 2 valence electrons, as you see here. And then now, since it has its 2 valence electrons, the next element will now have a D subshell on the 3rd orbit. Let me show you a picture of that. Right, and here's scandium. So as you can see, now it's starting its D subshells. It's going to fill the D subshells right over here. So when we went to calcium, it had the 2 S subshells. Remember, the 2 S subshells had to be filled first before we started putting a D subshell in the 3rd ring. By the way, with scandium, remember I said before in the video that if once you have a D subshell, they include that in the valence. So scandium will have 3 valence electrons because we have a D and the 2 S's in the other. Well, let's go back to the alkaline earth metals. I did mention the word alkaline. Let's make sure we understand what pH means. And we're going to talk about pH when we talk about chemical reactions in later videos. But pH just means potential of hydrogen, right? So I think I had a little pause there. But let's put our pen going there. So it is the potential of hydrogen. And really, basically, we're talking about whether something is an acid or whether something is a base. So, for example, 7 is neutral. 7 is basically water. Now, you can have alkaline water, which they're selling in stores, but water, basically tap water, has a pH of 7. So you say water has a pH of 7, but it could vary, right? And so obviously anything higher than 7 will be a base, and anything lower than that will be an acid. So you may think of, let's say, citric acid in fruits, right? I forgot to put the acid. Citric acid, I'll put it over here. Citric acid in fruits, right? That's acidic. What else can you think of as acidic? Well, what about vinegar, right? So let me make a better chart here. Clear that out. Let's make a better chart. Use a different color too. I don't use purple. Right, so we have our little chart here, and we have 7 right in the middle. Right, so again, the potential of hydrogen, 7. So we can say vinegar, we'll put a vinegar over here. Vinegar, vinegar is acidic. And over here, we can put as baking soda. And again, when we talk about acids and bases, we're going to talk more about this. But if you mix baking soda and vinegar, they'll react and they'll neutralize each other. All right, so vinegar has a pH of like 3, could have a pH of 3. And over here, well, blood, for example, blood has a pH of 8. But again, we're going to talk more about this. So anyway, the alkaline earth metals, when they combine, again, they don't want to be alone. They will combine. You won't find them alone in nature. They will create an alkaline solution. Very important to remember. All right, let's go back to the table here. So all these alkaline earth metals, they will react with water, just like the alkalis. They react with water. The only one that won't react too well with water is, and we got our pen going, is the top one, beryllium. So beryllium doesn't really react well with water, but the rest will, right? You put magnesium in water, it will react. You can create smoke and a flame, just like when we put sodium in water. All right. And again, sodium will react more violently in water than magnesium because, like I said, the alkalis react more than the alkalines. All right. So, and we have magnesium and calcium. You know these two. These are vital. These are vital for life. So we need them. The alkali earth metals are good conductors. They're good conductors, not music conductors, of heat, right, and electricity. But not like the metals of copper and silver and aluminum, or aluminium if you want to call it that. But they are good conductors of heat. And radium here on the bottom, we're going to talk about radium all by itself because it's very interesting metal when we talk about Madame Curie, who discovered it, and all the applications they were using with radium before they realized it was dangerous. But we'll have a separate video on radium. Now let's look at some of the solutions. So, and very important to know that, again, the alkaline earth metals, just like the alkalis, they don't want to be alone. I'm simplifying that, but I'm trying to say is that they will react. They will form other compounds and solutions. So you'll never see calcium by itself. So, for example, the calcium inside you, in your bones, and you think of calcium, let's just write calcium down here. You think of calcium, you think of, well, it's calcium. We need it for our bones, and it's true, but it's actually, and let me spell it for you here. It's hydroxyapatite. Let me write it. Sounds like a fancy word. Right? Hydroxyapatite. 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 I'll say it again, even though you say it a couple times, you'll get it. So all that is just calcium and phosphorus. Or phosphate, right? It's calcium and phosphate. And so again, in our bones, we can say calcium just to make it simple. Or, how would you pronounce this again? Say it a few times and you'll get it down. Hydroxyapatite. Yeah, let me phonetically write it here. So, here's high, drox, C, appetite. Like appetite, right? Something like that. But you get it, right? So, hydroxyapatite is calcium phosphate. It is what's in your bones. It's in our bones, right? And then we have calcium carbonate you might take if you have acid indigestion and so forth like that. So just to review with the alkaline earth metals, they're good conductors of electricity, good conductors of heat, of course not better than copper and silver. And they, when they combine, they will form alkaline solutions like we talked about. And they are very reactive, but not as reactive as the alkalis. And of course they have 2 valence electrons. By the way, here's magnesium, right? Kind of looks almost like sodium. So when you cut this, like if you cut it up, you see it's really silvery and shiny. But again, it will combine with oxygen very easily and have magnesium oxide. Combines very easily. So you leave this in air and it will combine with the oxygen. So that's magnesium. So a quick review. What 2 alkaline earth metals do we need for life that are vital for our life? Just 2 that you may think of. One right in front of you, right? Magnesium and calcium. And again, they all react with other elements. And the most radioactive is radium. And the one that reacts the most, again, will be radium also. All right. Next video, we'll do another family, the transition metals.